13 for double and half angle identities. So here's some new formulas we're going to learn and use. So these specifically are the double angle identities. And like before, I will give you these. I'll give you that sine 2x. So if you ever want to simplify sine 2x, it's 2 sine cosine. And we use this a lot. A lot of times when we see sine 2x, we're going to change it to 2 sine cosine. Not always, but a lot of the times. Cosine 2x has 3 different versions. They're all equally correct, right? There's cosine squared minus sine squared, which I use a lot for the problems we're going to do down here. Sometimes you want to change it to 2 cosine squared minus 1. Sometimes you want to change it to 1 minus 2 sine squared. These are more used for solving, which we'll talk about in the next lesson. These are to solve. So they're much more helpful to solve than anything else. This is to simplify, to find the exact value for. And then tan 2 theta, here's a tan formula. Again, most of the time I just use sine 2 theta over cosine 2 theta, but here's a tan formula for it. Here's how I'm going to give it to you on the quiz and test. I'll give it to you like that. Sine 2 theta equals 2 sine cosine. Cosine 2 theta equals either one of these three. They're all equal. So let's move on to our first example. Find the exact value of sine 2 theta if sine of theta equals 2/3 and theta is between 0 and 90. So first, let me show you what not to do. I see people do this all the time. They'll get sine 2 theta, and they'll see that, hey, sine theta equals 2/3, and they'll just plug in 2/3 for theta. That is wrong so many levels. I hate that. Please don't do that. First of all, notice it's not theta equals 2/3. That would have been fine. It's sine theta equals 2/3. So this does not make sense. So please don't do that. Instead, what we gotta do is this. Like I always like to do, you make a triangle in that quadrant. So it's between 0 and 90. So I draw my little triangle between 0 and 90. You always go to the outside and remember to go to the x-axis. It's sine, so SOHCAHTOA. And since it's sine, it's over h, so opposite is 2, adjacent is hypotenuse is 3, right? Opposite of hypotenuse. I gotta find my missing side, a squared, b squared, c squared, so a squared plus 2 squared equals 3 squared. A squared equals 4 and 9, so 5, so rad 5. Keep in mind we're in quadrant 1, right? All students take calculus, so everything is positive. So now how do I figure out what sine 2 theta is? Well, use the formula. Sine 2 theta is 2 sine theta cosine theta. So plug in, we have 2. For sine, we're going to plug in 2/3. Notice I plugged in for sine, not for theta. Sine theta equals 2/3. So the whole thing is 2/3. And then for cosine, I can find it using my triangle. Cosine is adjacent over hypotenuse. Rad 5 over 3. Multiply this all together. Now remember, notice when you multiply, guys, this is 2 over 1, so it's on top. So you get 4 rad 5 over 9. And that's the answer. So let's try another one like that. So same idea, sine of 2 theta, now they give us cosine, and they tell us between 90 and 180. So it's in quadrant 2 now. So draw my little thing, here's 90, here's 180. I'm going to draw my little triangle. So SOHCAHTOA, adjacent to so 1, 3. Adjacent to negative, hypotenuse is always positive, so it should be -1. But if you're not sure, remember, all students take calculus. So just by the fact that it's an S, I know sine's positive and everything else is negative. I gotta find my missing side, so I'm gonna do a squared plus b squared equals c squared. A squared plus 1 squared equals 3 squared. A equals rad 8. 9 minus 1. So this is rad 8. I'll reduce it later, but actually right now I'm gonna leave it like that. Now if I want sine 2 theta, that's the formula, 2 sine theta cosine theta. Just follow the formula. And then we plug everything in. Sine is opposite of hypotenuse, right? SOHCAHTOA, OH. Cosine, SOHCA, adjacent to hypotenuse. And then this is 2 over 1. Multiply everything together, you get -2 rad 8 over 9. And actually, now I'm going to reduce that. That is 2 rad 2, right? 8 is 4 times 2. Radical 4 is 2. So 2 rad 2. And I get -4 rad 2 over 9. So that's the process. If I do double angle identities. We're going to do, I'm not going to do all these. I'll do one more. I think you guys get the gist. And let's do a more fun one. Let's do this one. Now, it's actually kind of the same as the last one, but I don't have that many choices. So same concept. They give me cosine, so I'm going to draw my triangle over here in quadrant 2. And that is a bigger triangle than I wanted to draw. So let's try that again. I'm going to do it in the middle now. Quadrant 2. That's my best drawing of a triangle. It's not getting better, but there you go, kind of. So SOHCAHTOA A over H. This is -1, this is 3. Finally missing 7, we actually did that earlier, so radical 8. I know that from heart. Right, so we did that earlier. I want to find cosine 2 theta, we haven't done that yet. That's a different formula now. There's 3 of them. I prefer the first one here when I'm doing a problem like this. So when we're doing find the value between some things, I like to do the first one, cosine squared minus sine squared. You'll see why, because it makes it a nice problem. So cosine squared theta minus sine squared theta. Now again, cosine I actually have. I know cosine is -1 over 3. Sine I could find right here, opposite of hypotenuse, rad 8 over 3. Forgot to square them, because remember it's cosine squared minus sine squared. Now you have this square, you get 1 over 9. Minus, when you square both of them, radical 8 squared is just 8. 3 squared is 9. So remember that square goes to both. 1 minus 8 is -7 over 9. Like that. Tan 2 theta. So again, you can use the tan formula. I forgot what the tan formula is. I know the sine formula though. I'm just going to do the sine 2 theta over cosine 2 theta. Because that I know. And that's going to be 2 sine theta cosine theta over cosine squared minus sine squared. Right, so 2 times sine. Sine is opposite of hypotenuse, rad 8 over 3. Cosine is -1/3. On the bottom, actually no, it's already -7/9. We do that over here. So I do a little simplification. It was kind of hard to read. I'm going to get -2 rad 8 over 9 over -7/9. Right, this right here is just -2 rad 8 over 9. So you have this. Now remember, don't freak out with complex fractions. It's just a divide sign. It's the top times the reciprocal at the bottom. Right, when you divide by a fraction, you multiply by the reciprocal. These cancel. I get -2 rad 8 over -7, also known as 2 rad 8 over 7. Or if I'm trying to be pro about this, this is 2 rad 2, 4 rad 2 over 7. And that's the idea. That's how double angle formulas are used. Right, so just draw a triangle in the appropriate region, and then find out what sine and cosine is, plug into the appropriate formulas. Again, we'll use more of this when we do solving next lesson. Now we're going to do 2 more problems. This is a half angle identity. This is actually used way less than double angle identity, so you see double angle a lot more. But just so you're not totally lost, let me show you a half angle identity. It's the same process, same concept. Here are the formulas. Again, I would give them to you. And it's the same idea. Find the exact value of cosine pi over 2, theta over 2, if sine theta is -4/5 and is in the 3rd quadrant. So it's in the 3rd quadrant. Sine is opposite over hypotenuse. You can find the basic side by doing a squared, b squared, c squared. That's going to be 3. Now keep in mind you're going to the left, so that should be a -3. But if you're not sure, all students take calculus. So only tan should be positive in this quadrant. Everything else should be negative. Now they want me cosine of theta over 2. So I'm going to look over here. The formula for that is plus or minus, depending on what quadrant you're in. We're in quadrant 3, so it's going to be minus 1 plus cosine theta over 2. So let's plug our stuff in. Plus and minus. Actually, let's put minus. We're in quadrant 3. 1 plus, now cosine theta, again, just plug that. What's cosine of this thing right here? Adjacent right hypotenuse. Negative rad 3 over 5. All over 2. And that's the answer. If you want, we can simplify it, but that's the answer. Just plug it in, do that. Now let's simplify it, because you know what? Whatever. I'm going to simplify it. Common denominator, 5 over 5. So that's going to be 2 over 5 divided by 2. Now remember, when you do that, you're dividing by this. So multiply by reciprocal. 2/5 times the reciprocal. And I get radical 1/5. So by now we get the gist of how to do this. It's just, right, draw my triangle in the appropriate quadrant, quadrant 2 here, fill out the sides, and then plug into the formula. So we're going to skip those because they're the same. We'll work on it in class. Let's get to the next part of this, how to verify identity using this stuff. So you see this here, we're going to verify an identity, trying to match this. Now right here, 1 minus cosine 2 theta, that's not 1 minus cosine squared, so I can't make that sine squared. But I could simplify this and simplify this. So let me work on the bottom first. Sine 2 theta is 2 sine cosine theta. Now, cosine 2 theta is actually the hard one because there's 3 things, right? It could be cosine squared minus sine squared. It could be 2 cosine squared minus 1. It could be 1 minus sine squared. Now let's think about this logically. I want to have tan. So I'm trying to get, on this side, what I know tan is? Sine over cosine. Right, so tan is sine over cosine. I want to get tan, so I need a cosine on the bottom. I want to get rid of the sine here. So which cosine 2 theta am I going to use? I'm going to use the one that has sine in it only. I'm going to try to see if that simplifies. I'm going to use this one right here, 1 minus 2 sine theta. See if I can work something out there. So don't forget parentheses, 1 minus 2 sine theta. I think sine squared theta. Like that. Okay, let's simplify it a little bit. This should be the negative. And I'm going to get negative 1 minus 1 plus 2 sine squared theta all over 2 sine theta cosine theta. Now I still can't cancel out because there's a plus sign there, right? Can't cancel it on the plus. But 1 minus 1 is 0. So I just get 2 sine theta squared over 2 sine theta cosine theta. Now the squared and the sine cancel, and the 2's cancel, and I just get sine over cosine, which matches. So that's the idea. I'm going to do some more here. Look at this one. Sine squared plus cosine squared. And I got this. So I'm going to work with this side. Remember, you always want to work on the side that's a little easier to simplify. It has more stuff on it. So sine squared plus cosine squared, well, gotta rewrite it. Can't be lazy. Don't give me sine squared plus cosine squared. I hate that. Right, it's this plus this squared. So you gotta multiply it by themselves. Proper math. Distribute sine squared plus sine cosine plus cosine sine plus cosine squared. So let's look at this. Right here I have sine squared and I have cosine squared. Sine squared plus cosine squared, 1. Right here I have sine cosine plus cosine sine. It doesn't matter which one goes first. They're the same thing. Right? Sine cosine cosine sine are just 2 things being multiplied. It's like saying x, y, or y, x. Doesn't matter. So you get 2 sine cosine. Hey, and they match. So that's the idea of how to verify, right? It's the same concept, try to make the 2 sides match, but now you just have more tools to play with. You see sine 2 theta, you could change that. You see cosine 2 theta, you could change it. Now cosine, you gotta think about it though. Like what helps you? Like when I did this one, sine over cosine, I need to get rid of that sine, so I changed cosine 2 theta to a sine one. That I don't care about. And then the last one here. Let's do a quick application problem. A soccer player kicks a ball at an angle of 37 degrees with the ground with an initial velocity of 52 feet per second. The distance d, the ball will go in the air if it is not blocked, is given by this formula. In this formula, g is the gravity, acceleration due to gravity, and it's equal to 32 feet per second squared. And v is the initial velocity. Simplify the formula using double angle identity. So they want me to simplify this. Now that's a little tough. So they want me to simplify this. Now, if you notice, there's no sine 2 theta, cosine 2 theta. They want us to go backwards. So before we do that, let's look at our 2 formulas. That's 2 sine theta, cosine theta, cosine 2 theta. There's a lot of them, but cosine squared minus sine squared is one of them. then 1 minus 2 sine squared is the other, and then 2 cosine squared minus 1. So they want us to go backwards. Instead of trying to figure out sine theta and going this way, they want you to go backwards. They want you to look at one of these and try to go that way. Let's look at this top here. 2 and sine theta cosine theta. That's this right here. So instead of having 2 sine theta cosine theta, you could just rewrite that as v squared times sine 2 theta. Like that. That's how you simplify using doubling identity. Look at the pattern. It looks like this. Write it backwards, right? Sine 2 theta. Using simplified formula, how far will the ball go? So we're just going to plug our stuff in. The initial velocity they tell us was 52 feet per second. So 52. The angle is 37. And then gravity is 32. So I'm going to get 52 sine of 74 all over 32. Put that in your calculator and you get an answer. And that's it.